In this podcast episode, Adam Frank, a NASA physicist and astrobiologist, delves into a wide array of topics ranging from the search for extraterrestrial intelligence and the possibility of prior advanced civilizations on Earth to climate change, space exploration, AI technology, and the cultural impacts of scientific knowledge and misinformation. The discussion touches on the development of techno-signature research, the challenges of identifying intelligent life beyond Earth, the Curan hypothesis about extinct industrial civilizations predating humanity, and the complex interplay between science, technology, society, and politics. Adam Frank explains his early involvement with NASA as one of the first scientists to receive a grant explicitly aimed at searching for signs of intelligent life, not just biological life, outside Earth. The field, historically marginalized and underfunded since its inception in the 1960s, gained some traction only after the discovery of exoplanets in 1995. The realization that planets exist around other stars and could be Earth-like sparked a renewed interest in astrobiology and SETI, search for extraterrestrial intelligence. In 2018, congressional support led to NASA allocating funds toward Techno-Signatures, a modernized term for looking for evidence of alien technology through telescopic observations. Frank clarifies that the techno-signature search is distinct from UAPs and UFOs, which rely on disparate and often unscientific evidence. Techno-signature research uses high-powered telescopes to detect artificial illumination, waste heat, or other anomalies in exoplanet atmospheres and surroundings, focusing primarily beyond our solar system. The episode underlines the necessity of rigorous scientific methodology and cautions against conflating anecdotal reports of unidentified phenomena with credible evidence of aliens. One of Frank's notable scientific contributions is the so-called Curan hypothesis, named after the ancient Greek philosopher, co-developed with Gavin Schmidt. It asks a provocative question: could there have been an advanced technological civilization on Earth millions of years ago, prior to humans? They explore how one would detect such a civilization in the geological record, especially considering Earth's surface is constantly recycled by plate tectonics. The key takeaway is that traces of an industrial civilization lasting on the order of 10,000 years or less would be extremely difficult to detect after millions of years, as surface layers are subducted or eroded. Chemical evidence, such as isotope anomalies in rock strata, would be the best possible marker. For example, unusual spikes in carbon isotopes linked to industrial carbon emissions could serve as a signature visible to future scientists or alien visitors. Frank stresses that they are not claiming there was such a civilization. Rather, the point is to frame the question scientifically. How would we know? This allows the exploration of the long-term consequences of intelligent life on planetary environments and invites reflection on humanity's own imprint on Earth's biosphere and geology, particularly through climate change and energy use. Addressing a common topic related to UFO lore and fringe science, Frank discusses fundamental physics and why anti-gravity remains beyond current and foreseeable scientific understanding. He outlines the four known forces of nature: gravity, electromagnetism, the strong and weak nuclear forces, and explains gravity's unique feature: it only possesses one kind of charge, mass, which always attracts. Unlike electromagnetism, which has positive and negative charges that can be shielded or manipulated, gravity cannot be shielded or reversed. This is a profound physical limitation supported by Einstein's theory of general relativity and decades of experimental verification. Frank also critiques fringe theories and figures such as Townsend Brown and the Biefeld-Brown effect, emphasizing that while some phenomena may have niche engineering applications, like ion thrusters, they do not represent breakthrough anti-gravity physics. He urges a distinction between well-established scientific knowledge and speculative or conspiratorial claims, advocating respect for the scientific process as a meticulous, collective endeavor that continuously tests and refines theories. The conversation returns to UFOs and UAPs, unidentified aerial phenomena, highlighting the ongoing interest at the military and congressional levels. Frank shares skepticism about the quality of publicly available evidence, mostly anecdotal reports, pilot testimonies, blurry videos, and unverified radar signatures. He stresses the necessity for extraordinary evidence to support extraordinary claims, comparing this to the rigorous scrutiny required in mainstream science. Frank notes the existence of divided opinion within the military and intelligence communities themselves, with some officials advocating belief in UFO phenomena and others dismissing it. He points out that despite congressional hearings and whistleblower accounts, no undisputed physical evidence, such as recovered alien spacecraft or material, has ever surfaced. Memory and perceptual errors, especially in high-stress situations like combat, further complicate testimonial evidence. Frank acknowledges that while UFO phenomena are worthy of investigation, we currently lack the scientific data to draw definitive conclusions about extraterrestrial visitation. Turning to biology and evolution, Frank addresses the likelihood that extraterrestrial life, if it exists and has achieved intelligence, would not resemble stereotypical gray alien archetypes common in popular culture. Drawing on the principles of evolutionary convergence and contingency, he explains that while similar environmental challenges may lead to analogous biological adaptations, e.g., limbs for locomotion, the specific forms of life are highly contingent on random events and unique evolutionary histories. Frank amplifies the anthropological view that it is implausible for alien life forms to replicate the exact physical characteristics of Homo sapiens or hominids, the latter comprising only a tiny fraction of Earth's biodiversity capable of technological innovation. He discusses pedomorphism, the retention of juvenile features in adults, as a fascinating evolutionary concept that some speculate could be reflected in certain alien depictions, but stresses this remains speculative. Looking forward, Frank entertains the possibility that in thousands to tens of thousands of years, humans themselves may evolve or biologically engineer profoundly different forms, perhaps sexless space orbs as an example, with no guarantee that our descendants will resemble us today. Frank pivots to the topic of artificial intelligence, expressing cautious critique of current AI technologies, particularly large language models, LLMs, like ChatGPT. While acknowledging the impressive technical achievements, he underscores that present AI operates largely as statistical, autocomplete systems devoid of true understanding, consciousness, or creativity. These models often generate hallucinations or errors with confidence, limiting their reliability in critical applications. He warns of the risks associated with large-scale deployment of AI in economic, social, and political systems, especially given inherent biases, errors, and the pressure to adopt these technologies for profit rather than efficacy. Frank discusses emotional computing, systems that attempt to read human emotions via facial gestures, as an example of flawed approaches with dubious scientific bases. Concerns extend to autonomous weapons systems and socio-political consequences, where flawed AI decision-making could have dire outcomes. Frank advocates for public awareness and the right for societies to regulate or reject technologies that erode human agency or compound wealth inequalities. The discussion touches on humanity's ventures into space and the political, technical, and societal factors influencing them. Frank recounts the history of NASA, the Apollo moon landings, and the challenges of returning to the moon, emphasizing that political will and funding, not technological ability, have been the main limiting factors. He highlights the loss of experienced NASA personnel in recent years as a threat to future missions. There is critique of Elon Musk's ambitious Mars colonization plans, framing some visions as optimistic to the point of fantasy given current technological and economic constraints. Frank points out the significant challenges of interstellar distances, time dilation effects, and the feasibility of sustained human space travel. Regarding the moon itself, Frank discusses its unique size relative to Earth, its tidal locking, and its profound influence on Earth's climate and biology by driving tides and slowing Earth's rotation. He underscores the importance of the moon in Earth's history, suggesting that its presence may have been a critical factor enabling complex life. Conversations about Mars include the possibility that microbial life once existed there in a warmer, wetter past, and even the intriguing, though unproven, hypothesis that life might have panspermed between Mars and Earth via meteorite exchange. Frank notes the significance of recent exoplanet discoveries and the ongoing search for biosignatures. A large portion of the episode is devoted to climate change, framed as both a scientific and societal challenge. Frank summarizes the development of climate science from early hypotheses to current understanding based on fundamental physics. Increasing atmospheric CO2 due to fossil fuel burning traps heat and warms the planet. He clarifies the roles of various greenhouse gases, emphasizing that while water vapor is an important greenhouse gas, its levels are mostly feedback-driven and not directly influenced by human activity, making CO2 the key driver of current climate change. Frank also debunks arguments used in climate denial, such as misinformation about natural climate cycles or the role of water vapor. The discussion touches on past climate variability, mass extinctions, and natural climate phenomena, such as the Younger Dryas event, highlighting that the Earth's biosphere is remarkably resilient, but human civilization depends on climate stability. Frank believes that while the Earth itself will endure, the stability conducive to agriculture and human society is at risk. Frank expresses frustration with the politicization of climate science and the role of industry-funded misinformation campaigns in delaying effective action. He stresses that the core scientific consensus has been firm for decades, supported by thousands of studies and empirical data. Throughout the conversation, Frank emphasizes the value of the scientific method as a communal, transparent endeavor designed to prevent self-deception. He contrasts established science, built over centuries by thousands of researchers, with fringe ideas and conspiracies that often lack reproducible evidence or peer review. He reflects on the dangerous erosion of shared reality caused by conspiracy theories, misinformation, including moon landing denial, and political interference, warning that without a collective trust in scientific knowledge, democratic societies become vulnerable. Frank recognizes the challenges posed by new technologies like social media that can amplify falsehoods rapidly. This erosion threatens not only public understanding, but also the political and economic support necessary for sustained scientific progress, such as investments in NASA, climate science, and technological innovation. Frank highlights the interdisciplinary nature of modern astrobiology, where astronomers, planetary scientists, microbiologists, geologists, and climate modelers collaborate to understand life's origins, evolution, and potential existence beyond Earth. Conferences such as AbSciCon foster these cross-disciplinary exchanges. He notes the importance of integrating knowledge from diverse areas, including ancient myths and cultural narratives, which may encode long-lost memories of natural events, enriching scientific inquiry. This broad approach helps refine hypotheses about Earth's biological history and guides the search for life in the universe. Throughout, Frank returns to a central theme: humanity's role as an emerging planetary force capable of altering Earth's climate and biosphere. He likens current anthropogenic climate change to previous geological events triggered by evolutionary leaps, such as the rise of photosynthesizing microbes that transformed Earth's atmosphere. Recognizing our impact compels reflection on choices facing civilization, whether to mitigate climate change, develop sustainable technologies, and extend our footprint responsibly into space. The dialogue illustrates a cautious optimism mixed with urgency about navigating these challenges. Frank encourages listeners to engage with his writings and ongoing discourse through his newsletter, Every Man's Universe, where he shares insights on space, civilization, and intersections of science with spirituality. He also highlights his books, including The Little Book of Aliens, which expands on many themes discussed in the episode.